Okay. Are we ready? This is exciting, isn't it? Oh, you should definitely show me the signs of time. Definitely do that. I will talk all night if you let me. Just be careful what you wish for. All right, time to tidy up a little bit. Get all this in place. Okay. So, sorry to start a little bit late, but we had some problems.
What's the problem?
I'd like to start by asking a question that struck me as kind of surprising that people didn't know the answer to when we were discussing, a colleague and I were discussing the business of oracles, test oracles. Anybody know what an oracle is? What's an oracle?
Huge enterprise company.
No. No. Not that oracle.
Profit.
A prophet. Oh, that's interesting too. A prophet. What kind of prophet? Sorry? One that tells the future. That's right. The Oracle of Delphi. Delphi, excuse me. I'm not used to speaking proper Cyrillic. The Oracle of Delphi was a woman who would give you an answer to your questions. Mostly people wanted to know what the future was going to be like. So they would ask the oracle, and the oracle would tell them something. The oracle would tell them a vague answer. Not an answer that you could rely on right away. You know, what's is it going to rain tomorrow? If I want to do a picnic, is it going to rain tomorrow? And she would say, the rain occasionally falls upon the landscape. And of course, what you would do is you would take that and you interpret it whatever way you like. And then you would realize the next day, if it did rain, oh, the problem was with you. You had misinterpreted what the oracle said. What's an oracle when we're referring to testing? What's a test oracle? You can tell me that. Anybody can tell me that?
Experience.
Oh, that's an example of an oracle, maybe. That could be an example of an oracle. But what is an oracle?
It's an application that will do the thing and tell us, the result that we want it to be.
That was I think it was W.E. Howden's description of what an oracle was. He had this great idea back, I don't know, in the 1960s or 70s. He was writing about testing and talking about testing, and he had this wonderful idea. We could tell if our program is working correctly by developing another program that gives us the right answer. Well, this woman named Elaine Wyuker identified a problem with that, which is, what if the program that we're developing is a program that we're developing to find the right answer when we don't know what the right answer is? So obviously what you would do is you develop an oracle that would tell you the right answer, but then of course you would need yet another oracle that would tell you the right answer for the second one, so that the first one would be comparable. Doug Hoffman and Ken Kaner and James Bach started talking about this issue a few years ago, and James got me very excited when he started to help me understand what an oracle was, and since then we've been working on developing this. But I want to go back a step. The reason I want to go back a step is because I want to develop the idea of what oracles are and why we have them. We have oracles in testing because it's our job as testers, I would say, and I hope you would agree, to find important problems that threaten the value of the product, or of the service, or of the testing, problems in the testing, or problems maybe for the business, or problems for the project. All of these things are things that testers are tasked with doing. It's our job to try to find problems in the product. Right? Okay. So not thinking specifically of specific examples just yet, but what is a problem?
Something that we don't expect
Something that we don't expect and
and don't want to see.
don't want to see. I like that. I like that idea. Because a lot of the time, some people say, well, the problem is anything we don't expect. But of course, when I landed in Moscow yesterday, you know, it's still early April. I didn't expect it to be nice weather. And it wasn't, it was nice weather, and that wasn't the problem. Right? No problem. Similarly, some people say, well, it's, you know, if the product doesn't meet your expectations, that's a problem. Well, a few years ago, I bought my kids a computer. My daughter was 4, I think, or 5 years old maybe. And my wife's son, he was 12 or 13. And they needed a new computer. You know, the one that they had, it only had like a gigabyte of hard drive space or something like that. That was about it. And they wanted to play games and so on and so forth. So we went out and we bought them a new computer. Now, at the time, we didn't want them to have a fancy, beautiful computer because you know how kids are. They spill stuff, and they break stuff, and they lose stuff. So we wanted to get them, you know, a fairly cheap computer, let's face it. And the only computers available at that time were, well, they came with Microsoft Windows Vista. You're applauding. Why? You know, it's sentimental? Is it Stockholm Syndrome, where did you become a prisoner of Vista and learn to love it? Is that the idea? Yeah. Well, you know, we got it home and I set it up and so on. But I expected Vista to suck. It sucked. It met my expectations. I hated it. They kept asking me, do you really want to do that? Do you really want to do that? Yes, I just asked you to do that. I really want to do that. Did you press that key? Vista asked me. Are you the one who pressed that key? I thought, you know, if you were an employee, I would fire you the first day. Why do you keep asking me who I am? So, what's your name? Constantine. What Constantine just said, which I think was really terrific, he says, something we don't expect and that we don't want. That's really key. A problem is something that we don't want. Now, I thought I would look into this because a few years ago I went to a very good little workshop run by Don Gray, part of the Jerry Weinberg community, and he talked about what a problem was. Oh, it's this stupid problem. This stupid problem. The problem is, I want PowerPoint to do what I want with this thing, but PowerPoint doesn't do what I want. It just does what I expect. Wait a minute. Where's my? It's over there. It's over there. No. I know what the problem is. I know what the problem is. So I did a similar workshop this week in China, actually, with a group of Chinese testers. Isn't that beautiful? Just work. And I asked him the same kind of question I'm asking you. What is a problem? The first answer I got in this communist country, not a capitalist country, no. First answer I got was, a problem is something to lose money. China's changed a lot. Problem might be, said somebody else, something that doesn't meet expectations. But then they weren't as careful as Constantine was because they didn't add that extra element. A problem for somebody in testing could be something that annoys or frustrates a user. And then we had one guy or a woman, I don't remember, but that's not a problem, who reported that an obstacle, or the problem is an obstacle that hinders the achievement of a particular goal, objective, or purpose. I thought, wow, this is like a human dictionary, this person. That's amazing. The idea about problem that I heard a few years ago was this one. That a problem is a difference between what is perceived and what is desired. What we see or observe and process and believe, and what is desired. Now that comes from a guy named Thomas Dewey, John Dewey, 1930s, and it was from a paper or a book called How We Think, a Restatement of the Relation of Reflective Thinking to the Educative Process. That was a definition used by Don Gray in the workshop. That's what we came up with as a good working idea of what a problem is. But then a few years later, I stumbled onto this. A guy named G.F. Smith. I read about this in a book called Sense Making in Organizations. Really cool book, a little bit hard to read sometimes. But G.F. Smith said that a problem is an undesirable situation that is significant to and may be solvable by some agent, although probably with some difficulty. Okay. So let's look at these two things here. Oh, by the way, that was originally in a paper called Towards a Heuristic Theory of Problem Structuring. In not a computer software thing at all, but in a magazine called Management Science, or a journal, I guess. What do these two things have in common with each other? Yeah, desire seems to be the common thread there. I liked this second one a lot, actually, because it addressed, if you like, a problem that I had with the first one. And the problem with the first one is there's no agency there. That is, there seems to be no person behind the idea of what a problem is, what the difference is, what the perception is, what the desire is. I mean, those are all things that are abstract. They're not solid things. They're not real things in the sense that you can't put your hand on it and touch it. They don't have a concrete substance. They're real in the sense that a real person might experience or decide those things. So, right around that time, right around the time that I was looking at this, I coined something called the relative rule. I'm very proud of this. It's my first general systems law. My first general systems law, the relative rule, was inspired by Jerry Weinberg saying that quality is value to some person. And, well, quality is value to some person. Okay. And then I thought, that's a special case of a more general rule, a more general kind of idea, which is that for anything X that is abstract, X is X to some person. So, for example, hot out. Well, hot is hot to some person. That's expensive. Well, expensive is expensive to some person. There's lots of people for whom money is no object. There's something else they want. To some people, JavaScript is not a programming language. It's not a programming language. JavaScript is a programming language to some person. So, all of these things, all the things that we think about are true or important in the world, those are all relationships. That's an interesting thing, it seems to me, because a difference, according to some person, between what is perceived by some person and what is desired by some person, it's lots of fun to play with that, because as testers, I argue, it is our job to recognize that things can be different, as Jerry Weinberg said. A tester is somebody who knows that things can be different. And one of the easiest ways to show that things can be different is the idea of a difference. You go to a programmer and you say, this isn't doing exactly what I thought it would do. And the programmer says, yeah, but that makes no difference. Between what is perceived. Well, perception, that's a subjective thing, isn't it? What I see and what you see, they may not be the same. For example, is this glass half full or half empty? What's that? I say it's neither. I say the glass is too big. All right? Oh, thank you. I know it's very clever. So I stole it from George Carlin, a comedian. But that's true. It's a perception that the glass is half full. Perhaps the glass is too big. Too big for the amount of water that I have in there. I want a smaller glass. So, what is desired? Well, desire is absolutely a subjective thing. But subjectivity is okay because subjectivity is one of the ways that we think more specifically about the world. Recognizing that things can be different is an important skill for a tester. So I wanted to add to that. Inspired by this one, because this one, the second one here, says it's significant to and may be solvable by some agent. There's somebody involved here at both the significant to and solvable by part. And what this leads to, it seems to me, is that sometimes we can address a problem or fix a problem by changing the difference, fixing the bug, or by changing the perception. How would we fix a bug by changing the perception? Well, we've all seen it. We've all seen it happen in those meetings when we say, that's not a bug, or that's a bug. And the product owner says, and everybody else, we can all say this together, that's not a bug, that's a feature. That's right. By what is perceived and what is desired. Well, here's another one. What is desired? Well, it'd be a real good idea to fix this bug before release time. We don't have time to fix this bug before release time. I want to fix the bug, but I'm going to change my desire. I'm going to put one desire on top of another desire, and I'm going to say I'd rather ship this program and fix the bug. So, we can change our desires, we can change our perceptions, we can change our differences. That's why I would add, as a thought balloon, I wouldn't necessarily say this every time, but I think I'd like to think it. I'd like to keep it in the back of my head that a problem is a difference, according to some person, between what is perceived by some person and what is desired by some person, and those three people could all be different. After all, as testers, we report a problem. We are the according to some person. We report a difference between what is perceived by some other person, like the programmer, and what is desired by the customer. So there's a lot of different things that could be going on here. A lot of different people who could be involved, and it's important for us to keep those things in mind. This also helps to keep us humble as testers, which is we don't own the quality of the product. We might see a difference between what is perceived and project on somebody else what is desired. But we might not be right about that. We might be wrong about what they would desire, what they would perceive. So this helps to keep us, I would argue, skeptical. Skeptical not only about the product or about the project or about the customer, but about ourselves. Skeptical, by the way, does not mean the rejection of belief. As James Bach points out in his book, Secrets of a Buccaneer Scholar, skepticism is the rejection of certainty about belief. I'm not saying that something isn't true, I'm just saying I'm going to be professionally unsure as a tester that what I see is what's really there. So, what all this comes down to, look at all these people. According to some person, by some person, by some person, by some agent. The important thing to remember here is that bugs, problems in the product, are not actually problems in the product. They're relationships between the person and the product. There's nothing in the product that is automatically a problem. And I'll give you an example of that. Again, another Jerry Weinberg story. He was working on some stuff at IBM in the 1960s, and part of what he was doing, if I'm telling the story correctly, which I think I am, and even if I'm not, it's okay, because it's a good story. He was working with the operating systems group, and the operating systems group had a problem. Their problem was they wanted to test the capacity of the system to respond to things that could make it crash. But they kind of had a problem because all of the test ideas they had for making it crash were kind of predictable, and they wanted to find something that was unpredictable, that wouldn't crash according to predictions, that would crash according to things that they couldn't explain. Meanwhile, not too far away from them, just down the hall, kind of, was a group that was building a compiler, and the compiler had a terrible problem. It would crash randomly, and they couldn't figure out why. So here's a compiler that crashes randomly, and here's a team that needs a product that crashes randomly. The fact that the compiler crashed randomly was a feature to the operating systems group, although it was a big problem for the compiler people. It was just what the operating systems people needed. It was a perfect product for them. That underscores the fact that your problem is a relationship between you and the product, whatever problem you're experiencing. Now, that's not to say it's invalid. It's not to say that it's invalid. It's a problem for you, or it's a problem potentially for the customer, but it is a relationship. It's not intrinsically in the product that there's a problem. The common element to all problems, I believe, it centers around this idea of desire. Looking for what we want. That's what we're seeking. So, what is an oracle then? This is somebody else's water. But I don't think they've had any. So, no problem. the oracle used to be the thing that would give you the right answer. But you know, rightness of an answer is also a relationship. The rightness of a program is also a relationship. This whole idea is very controversial when James first started talking about it in the 1990s, this idea of good enough software. Software doesn't have to be perfect, but it does have to be good enough. So what's an oracle? I think it's more important for us to recognize that an oracle is not something that gives us the right answer, but an oracle is something that alerts us to the presence of a problem. Now there's a lot of stuff that goes into that. There's a lot of nuance and so on, and that's pretty much what I'd like to talk about today. So, you know, we're through the introduction at this point. An oracle, say James and I, is a means by which we recognize a problem that happens during testing. A way that we can say, oh, problem, or, no problem. Now, it's very important for us to keep in mind something interesting. We can see something that looks like a problem and be pretty confident that it's a problem or that it'll be a problem for some person. But there's nothing in the world that can tell us no problem. Not conclusively. There is no test for always. There is no test for never. There is no test for in every circumstance. So this gets down to an important difference, a distinction for which, by the way, this is why it's important for me to work from my own machine. But that's not possible today, so I'm going to talk about this because it's something that's very important to me. A distinction that I started to make about 5 years ago between testing and checking. I think over time this has proven to be a kind of powerful way to illustrate some interesting problems that we've run into in the world of testing over the years. Let me explain. We have this idea that one of the things we can do, especially with an automated tool, right, with some automation, is that we can set up a set of conditions that we expect the program to run in, and then we can set up a decision rule such that when we observe the program running and apply the decision rule, we can come to a conclusion, pass or fail. Yes or no. 1 or 0, on or off, green or red. It's a nice idea. What it means, of course, is that we can run a program and have another program operate and observe that program and then apply decision rules algorithmically. Can anybody think of a problem with that? If all the decision rules pass, then we've got a good program, right? No, why not? What? The decision rules may be broken. Oh, that's true. It's possible that the program that we wrote to check the program under test, it's possible that the checking the program has a problem and the program being checked doesn't have a problem. Any other problems with the idea of having, let's say, an automated suite of 10,000 test cases? What's that? Could be slow? That's why we want to automate them. Right? You know, testers are slow. People are slow. They're imprecise too, they make mistakes all the time. If you make a tester go through a test procedure, you'll find that the tester every now and again makes a mistake and forgets a step or misses something or forgets to do something, or even worse, the worst thing of all is a tester misinterprets something. And so managers have this wonderful fantasy. Let's get rid of the tester by automating all of the tests. Sounds like a great idea, doesn't it? Well, not in this audience, right?
It's hard to support.
What's that?
Hard to support.
Hard to support. Oh, yeah, that's probably true too. Yes, 10,000 of anything is hard to keep track of. I don't, I don't do 10,000 of anything I like, basically. Don't know about the rest of you, but just the idea of doing something 10,000 times, yikes.
Wrong scope.
Wrong scope. Tell me more about that.
You can have 10,000 tests, but you don't have a test which found the problem.
That's possible. Those 10,000 tests might not have identified all the possible problems. See, here's the deal. The scope of possible problems in a product is infinite. The scope of problems that we can anticipate in advance of encountering those problems is very limited. What test cases, and certainly checks, do is that they set up in advance a set of conditions by which we would deem the program correct. But as James Bach has said, I'm not worried about correctness. I don't test for correctness. He said, you might as well ask me if this program is virtuous. I don't test for virtue. What I test for is the presence of a problem. And the trouble with checks, as powerful and as useful as they are, we're not saying don't do checking. What we're saying is checks are limited because applying algorithmic decision rules to a product depends on those algorithmic decision rules referring to a problem that we care about. And that means anticipating what those problems are. Now, I think our experience ought to tell us humans are pretty lousy at anticipating problems. I mean, we're not bad at it, but we're not great at it. And we're always developing something new. When we're developing software, we're always developing something that's new and that has opportunities of failing in new ways, ways that we've never thought of before because we've never developed a product just like this one. If there were a product just like this one that worked, we'd drag a copy of it to a CD drive or to a flash drive, and we would put that into another machine someplace else, and everybody would be happy. But we're in the process of developing software, developing new ideas, responding to new requirements, responding to new market conditions. So after kicking this idea around and looking at the sort of unbearable lightness of test cases, James and I have refined our notions of testing and checking. Checking is an observation linked to a decision rule such that the observation and the decision rule can be applied algorithmically. But that's only a part of what testing is all about. Testing, we say, is learning about a product through experimentation. Learning about a product and evaluating it through experimentation. And it is a characteristic of experiments that they sometimes reveal surprising results. It's not just about hypothesis checking. Experiments aren't like that. Experiments are about finding out new things that were not anticipated by the hypothesis, that might happen in parallel to the hypothesis. So if we want to be good scientists, which I think testers need to be, we have to recognize that testing does not merely involve checking to make sure that a product behaves in a certain way, given certain inputs at a certain time, we have to recognize that testing is learning about a product by evaluating it through experimentation, which includes to some degree, and which does not include a whole bunch of other stuff, by the way, modeling the product, studying the product, conjecturing, asking what-if kinds of questions. It also includes realizing new things about the product by observation. So there's lots of things that are going on inside the process of testing, some of which is checking. Now, if you talk to certain agilists, they will tell you about their acceptance tests and how. If we set up a set of acceptance tests, before we start building this particular product or feature, and then we run those acceptance tests, and those acceptance tests all pass, then we will know we're done. Any problems with that?
Incorrect acceptance test.
What's that?
Incorrect acceptance test.
Incorrect acceptance test. Well, that's possible, I guess. But here's the real problem, as far as I'm concerned. A product can pass every single acceptance test and still have terrible problems in it. Show me, as Ken Kainer said in 1983, I think, the first version of testing computer software, he says, show me your acceptance tests. I can write a program that passes all of those acceptance tests and still has problems with it. And he says, if I can do that on purpose, I think it's possible for a programmer to do that by accident. So we could do that. In fact, I was playing this game a little bit earlier with somebody, Igor. No, it wasn't Igor, it was somebody else. Let's play the beer game, okay? Right. As you can tell, I like talking about beer. Everybody can relate to beer. People can relate to beer. So I order a beer. Oh, it's you. I was playing this game with you, right? The beer game? No. Yeah? Yeah? Yeah. Okay. So, give this away now. I go into a restaurant. We go into a restaurant together, and we decide, you and I are going to have a beer. So we order 2 beers. And the waitress brings us 2 beers. Any problem? What? Could be not the beer you wanted. Okay, what beer do you want? I'll have one too. What beer do you want? What's that? Slovish? Scottish beer. Okay, so she brings us a Scottish beer. Everything okay? No. It might not be. Well, how do the Scots do it? Are the Scots like the English, where they like it really warm, or the Scots like the Irish, who like Guinness to be cold? I don't know. I've never. Well, I have, but I don't remember. Let us just assume, for the sake of argument, that the Scots like their beer, and we like it too, of course, around 8 degrees Celsius. What's that? All right, so we set up a test. I check. Here's the beer, and we dip the thermometer in, and the thermometer says 8 degrees Celsius. Everything okay? No, why? What? The beer could be off. Old. That's right. It smells pretty bad. It smells pretty bad. So we set up another check. 8 degrees, and there's a label on the beer that has the sell-by date. Okay, and so it's got to be inside the sell-by date. Right? So it's not old, and it is 8 degrees. Everything okay?
Less glass can be broken, so it should be delivered today.
The glass could be broken. Okay, so we want an intact glass, 8 degrees, not before the sell-by date. What?
No.
Oh, there's no alcohol in the beer. That's a nightmare. All right, so let's see. We're going to check it to make sure that it's got alcohol, that it comes in an intact glass, 8 degrees, and what's that? There's a fly in the beer. Okay, there's a fly in the beer. So, no flies, 8 degrees, intact glass, a sell-by date. Everything okay?
Yellow color.
Yellow color. Ew. This beer looks like... Never mind.
Have you ordered 2 beers for each of you or just all together?
That's another thing that happens. A waitress shows up with 4 beers. Right? Who said 2 beers? She brings 4.
The waitress should bring it today.
What was that?
The waitress should bring it today.
Ideally today would be good, right? Probably within an hour or 2 of us sitting down, yes. You
The glass
see,
is dirty.
what's that?
The glass is dirty.
The glass is dirty. It's not broken, but it's filthy. There's something bad on the side. Okay, so
Capacity of the glass as well.
the capacity of the glass, that's right. It's a glass this big, and she's put it in the tray, and she's poured a liter of beer into this glass. Oh, that's right. We've got an entire glass of foam, and then there's this much beer in the bottom. We could play this game all day, and since you are great testers, I could set up 1,000 checks for the beer, and you will come up with something that I didn't anticipate. The trouble is, if I program those checks, and then run that program on the beer, then what I will discover very shortly is that there's always something that can get through what I anticipated and what I set up. That is why we need to test, because the properties of the product that we are developing are not always obvious to us from the beginning. We need to develop experience with the product. We need to do experiments on the product. We need to get to know the product. We need to learn about the product through experimentation. Not only so we can show that the product works. I mean, to some degree, we can't do that. We can't show that the product works. We can show that it can work. We can show that it might work. But we also learn about how to test the product by testing the product. That's very important. From the beginning of the project, we don't know the product well enough to test it. And so part of what I do, and part of what you do when you're testing the product, is you're learning how to test it. Those things that we call the requirements, that big pile of paper sitting there on the desk, are those the requirements? You'd say they are, but they're not. They're documents that represent the requirements. And those documents that represent the requirements were written a while ago by somebody who wanted something from the product, or by somebody who talked to somebody who wanted something from the product. And therefore, they may be out of date, they may be inconsistent, they may be incomplete. Well, they're always incomplete. For example, how many people have seen a requirements document that says at the end of each bullet point, 9.4.6, at the end of the paragraph it says, and the product shall not crash. And the product shall not annoy or frustrate anybody who is using it. And you could put all those ands in. It's kind of like the beer game, isn't it? And the product shall not have anything in it that would make anybody upset at any time. But really, in a way, that's kind of what we're shooting for, or at least we can infer by interacting with the product requirements that are tacit, not written, not told, not spoken. How many people have seen a requirements document that says the system upon which the customer uses the computer, or uses our product, should have a working keyboard? A keyboard with all the letters still on it. By default, well, yes, by implicitly, tacitly, but it's never written down that way. In the same way that we never go into a restaurant and say, I have a specification here for beer. So now the question is, how do we recognize problems when they happen in testing? How do we recognize a problem?
Some kind of feeling. What's going wrong?
A feeling. A feeling? Come on, this is software development. There's no place for feelings here. Yeah, a guy said that. I gave a talk on emotions in software testing in Toronto a few years back. And my friend Lynn McKee, she went back to her office back in Calgary, and she said to her boss, I just saw a really interesting talk on emotions in software testing, the role of emotions in software testing. And her boss said, there's no role for emotions in software testing. And she said, well, yeah, that's funny, because I watch this thing, I think there kind of is. You made a very persuasive case. And the guy says, there's no role for emotions in software testing, which is a surprisingly emotional reaction for somebody who's saying that there's no role for emotions in software testing. You're way ahead of me at the moment. I'm going to have to catch up to you. But as it turns out, I think that a feeling is in fact the very first step in recognizing that there's a problem here. Let's talk, though, about some principles. Somebody said comparison. Yeah, you said comparison? I think comparison's pretty good. Let's see if I can use this computer cleanly enough and well enough that, oh my goodness, hair trigger on this mouse. This is kind of good. I kind of like it. Okay, so comparison. Comparison what to what? Expected and actual results. All right, so let's do this one. Let's click here and we'll go here. This is my bank account a few years ago. Well, let's just have a look at it. Expectations. First of all, I have never seen a bank balance of $78,000 in my bank account. Never. Never close. Not even. So, that was unexpected. But here's the really unexpected part. Let's check this out. After I had $78,000 here, I spent $300, and my balance went up by almost $7,000. Not what I expected. And the desire part, that could be okay, except I suspected that nonetheless, even though that might be part of my desire, there still might be something wrong here. I paid off a couple of airline tickets and a big hotel bill and all that sort of stuff because I was traveling around, and I paid $3,450, and my balance went up by almost $7,000. Then I spent $73 and $73.34, and my balance went up by another $7,000. This violated an expectation that I had. I'll give you that, that's for sure. All right. Any other ways in which we'd recognize a problem? What's that? Okay. So actually, I've been thinking of changing this user expectation to also user desire. But I'm a tester. As a tester, I'm not the user of the product, and thank God for that, because otherwise I'd never release, anything. The product doesn't have to do what I want it to do, thank goodness. Otherwise, no product would ever get shipped, right? I keep talking about that, and that's just because I'm fussy. But my previous experience of the product, that's actually an interesting one. Let's try that.
But anyway, you compare your previous experience with the result that you have.
Okay, well, we might, but let's have a look. Here's consistency with history. Previous experience with the product. I had experience with Microsoft Word. This is like, I don't know which version it was. This is the next one. This is Word 2003, I think. And I was baffled when it came out. How do I print? There's nothing on here that would let me print. Because Microsoft, as usual, had run Word through the new product menu scrambling feature that Microsoft seems to apply to every new release. Now, you see, this is interesting because I saw this as a problem and Microsoft didn't. Microsoft liked the ribbon. I think anybody, the guy who invented the ribbon should be strangled with a ribbon. But that's just me. Any other ways that we'd recognize the problem?
You can ask people who are someone who is experienced in that area, so they can help you to provide you with the result that you should see, you expect.
Okay, so if I talk to an important person,
To help you compare.
oh, absolutely. If I talk to somebody who is important, and they say the product should do this, or the product does this, and the product is inconsistent with that, the product is inconsistent with a claim. Something to be a problem just because it's inconsistent with something. For it to be a problem, for it to be a problem that matters, it has to matter. It has to have some risk associated with it. The risk of causing harm or annoyance or loss of value to a customer, to a client. But to that end, I'm not sure that that is something that allows us to recognize the problem. That's about the significance of the problem.
I mean, if you just think about the impact, if it's fine, this is a problem. If it's small or even customer will not buy that, that's my problem with that.
Well, I take your point, and that's true. But I'm going a step before that. Before we start to evaluate the significance of the problem, the impact of the problem, how do we recognize a problem at all? Something that might be a problem, yeah. Yeah. Uh-huh. Okay, so if the product is inconsistent with purpose, we'd expect that there's a problem. This says, this disk or device contains more than one type of content. What do you want Windows to do? I don't know. It's not offering me anything. The product is inconsistent with the goal or the purpose that is either explicitly or implicitly part of the design of the product. The user wants to get something done. I don't know. What's next?
I think we could see that reality is changing. Now expectations can change.
If the product is inconsistent with our notion of the way the world should work, right? The reality that the product is not doing what seems to be real. This is one of my favorites. So my wife and I are flying from Toronto to Newark. Toronto's up here someplace. And after a while, we get down near Poughkeepsie, New York, which is a little town. And we start flying around because Newark Airport is always super busy. Just like Kennedy and LaGuardia, the space around New York is busy, busy, busy. There's lots of planes coming in. And if anything goes wrong, there's going to be delays. So they build that into the schedule. And the plane just flies around for a little while longer. They put it into what they call a holding pattern, and it goes round and round for a little while. In this particular case, down around Poughkeepsie, they sent us into a vector like that, and they made us go up around here, and then we came down here, and then we shot across to Brussels. Now you say, oh come on, it couldn't have been Brussels, but I looked at the map, and it said that we had gone 7,000, maybe it's farther than Brussels, we'd gone 7,000 miles this way, and 7,000 miles that way, and there's another screen that comes up here on this thing. And the other screen gives you the distance that you've flown. And the distance that we've flown is 14,000 miles, which is really impressive because it was a little regional jet, you know, with about 5 hours worth of fuel on it, probably at most. And, yeah, it's also inconsistent with my experience of the world. My experience of the world says that airplanes don't fly in an absolutely straight line for any length of time. But anyway, that's what the map says. We went all the way over there, all the way back over here, and that's just not consistent with my experience of the world. So I looked at this and I said, problem. Anything else? Any other way of recognizing a problem? What's that? Something crashes. Well, how do you know that's a problem? Well, first of all, it's inconsistent with purpose, but it also, this is an interesting one. This one is interesting because, this one, weirdly, it's the opposite of the other ones. When we see something that looks like a problem that we've seen before, that is, when we see the product behaving in a way that's consistent with patterns of familiar problems, we suspect that this one's a problem too. Oh, I've seen that. That's a crash. Interesting, that. It reminds me of something important about the difference between Microsoft products and Apple products. We have a new quality criterion. We have a big long list of quality criteria. And when this thing first came out, when I first got my copy of, or my first iPhone, look at that. This thing just oozes charisma. Charisma is the quality characteristic we're talking about here. This thing is just so lovely and gorgeous. It has a nice heft to it. It feels kind of heavy and substantial. But it's got elegant lines and curves and designs on it, and it's beautiful. And the best thing about it is, when it gets into trouble, when an application on this thing gets into trouble, what happens? It goes away. It goes away. And then you start it up again, and it comes back. It's so wonderful. It's so wonderful. It's so wonderful you almost forget it doesn't work. Apple products make you forget they don't work. Microsoft products remind you they don't work. Look, I crashed! I crashed! Yep, I crashed! Hey! You want to tell Microsoft I crashed? Yes, I crashed! Hello, crash! Anti-charismatic. Not charismatic at all, as far as I'm concerned. Any other way that we'd recognize a problem?
To have a pilot group of users.
A group of users?
Yes, we should.
Okay. All right. So I want to just review. That's a good idea. That's a good idea. Because what I want to review here is this. Oh, here's another one, by the way. Explainability. If a product acts in a way that we can't explain, we suspect that there's a problem here. Now, this one's amazing to me because there's like 4 things in this dialogue that I can't make any sense of at all. Look, here's the program it comes from. A program called DLL? Nah. An attempt was made to load a program with an incorrect format. What program is telling me this? What was actually tried here? What program? What format? And I'm supposed to say okay? I can't explain any of this stuff. I have no idea what's going on, and therefore I suspect that there's a problem here. You've seen that one, and you've seen this one. What we have not seen yet is this one. I love this one. You know, there's people who are pushing the idea of a software factory. Factory approach to software development. I'm sorry, I don't see a software factory as being a manufacturing thing. Software is more like a design studio. So I don't like the factory guys very much. It's not assembly and it's not construction that we're doing. We're doing design. We're doing problem solving. We're doing engineering. We're trying to create products that solve problems for people in an elegant way. The assembly line metaphor, the construction metaphor, it doesn't cover that very well. And so whenever somebody talks about a factory, I always get a little bit upset. But then they come along and they help me make my point. Please, PHP print contact us note for a detailed white paper on software factory. And then down here, right, it says the fundamental premise behind software factory is that any enterprise application, maintenance or development, PHP Print 4 standard service type Node 3. Enterprises can now complete all their product development, specified number of each of these services. I can't, this makes me happy because it underscores how this is not a factory process, it's not a mechanical process, it's a human process. Comparable products, the idea that that in a way, that's what a check is. A check is a comparable product too, but there's lots of different versions of comparable products. What's a comparable product to Microsoft Word? Yeah, Open Office, Writer. What else? What's that? Google Docs. Yeah. Pages, all right, Pages on the Mac platform, What's that? Ebby Word? Some products I'm not familiar with, that's cool. What about Notepad? Is that comparable to Microsoft Word?
What you propose? If you want to achieve a word processor, you use Word. If you want to write text, you use Notepad.
Okay. Could we, for example, take some data and put it into Word, and then save it as a text file, and then open it up with a comparable product like Notepad, and observe a problem potentially? In that sense, Notepad is comparable. Now, your purpose, that's a different story, right? If your purpose is to have a full-featured word processor, just like this Jen says, Notepad ain't it. But if your purpose is to be testing Microsoft Word and have a comparable, something to compare it to, how does it handle text files, just basic ASCII text files? Then Notepad might be an appropriately comparable product for that purpose. All right, let's go deeper. What about, do we have any Unix or Linux geeks here? It's Russia, there's got to be one or two. WC, you know what WC is? Not the loo, not the toilet. The WC, the command line program. Word count. Is that a comparable product to Microsoft Word? No? Well, it does. It has a command line, but it's not a very sophisticated user interface, and you can't use it for word processing. But what if your goal were to test Microsoft Word's word count function? At that point, then WC would be comparable on that level. So, I just want to make this clear. When we talk about a comparable product, we're talking about anything by which you could make a comparison of some dimension, some feature, some aspect of the product, and say, oh, you know what? Those things should be consistent with one another, and they're not. For that reason, Halo 4 is a comparable product to Microsoft Word. Halo 4 saves data, Word saves data. If there's a problem saving data in Word, then we suspect that there's a problem. seen this one. Here's another one. If a product acts in a way that's inconsistent with itself, for example, Microsoft Word, bottom left-hand corner of the screen, has a count of the number of pages in the document, and if your page numbering starts at 1, and you see a different number up there to the number down here, you suspect that there's a problem of some kind. Now, there might not be a problem. Somewhere in the document, somebody could have changed the page numbering, which is perfectly okay. It's okay for them to do that. So that what that underscores is the idea that oracles are heuristic. A heuristic is a fallible way of solving a problem or making a decision. A heuristic is something that helps us learn, that works, by and large, generally, mostly, quickly, cheaply. A lot of the time, a lot of heuristics are cheap, quick, inexpensive, immediate, even. But they're not perfect. Oracles are special cases of heuristics. An oracle is something that allows us to make the decision, is there a problem here? But it can fail. An oracle can mislead us. Here's an illustration of the principle that a product should be consistent within itself. This is my new, on the day I bought it, ThinkPad. Here we've got 96% battery power available. Here we've got 92% battery power available. In the same dialogue, 91% battery power available. That inconsistency makes me wonder, is there a problem here? Oh geez, only 10 minutes? Holy cow. All right. Standards, statutes. If a product is inconsistent with widely accepted or relevant standards, we expect that there's a problem. There might be a problem here. There might be a problem here, but we're never sure about that. Here's why. As a tester, I don't need to know for sure whether something is a problem or not because I don't make the decision about that. The product owner does. The people who own the product, they get to decide whether the product that they've got is the product that they want. They get to decide whether if I identify something and say, hey, this looks to me like a problem, they get to decide whether they're going to fix it or not. They get to decide whether they're going to spend development time, whether they're going to slip the schedule, whether they're going to change the scope of the product, whether they're going to solve the problem or address the problem or ignore the problem. I mean, you could address the problem, don't fix it, feature it, right? You could do it that way. You could solve the problem by fixing it. You could solve the problem by just taking that whole feature out. There's any number of ways that you can solve the problem. As a tester, what I do have to do is I have to perform an act of explaining why something that I feel is a problem is a problem. And that's the key to what the people at the back were talking about just then. I have to be able to cite good oracles. I have to be able to take a feeling that I've got about the product and convey that feeling to somebody else, to other people, to other stakeholders. And here is the interesting skill associated with that. The first thing is to recognize that any feeling that we have about the product as we're testing it, heuristically points to a problem. Now it could be the case that I'm frustrated. Why? Because I just had an argument with my wife's son again. He's 18 years old. He wants the car. I don't think he should have the car. I'm annoyed by it. I'm looking at this program and my emotional state has been primed to see problems everywhere, especially to do with cars. But I noticed this a few years ago when a tester came up to me and asked, so, all your class is very interesting and stuff, and I have this question, how do I deal with all this boredom that I experience when I'm doing testing? And I said, first thing you have to be aware of, if you're bored during testing, it's like being bored in your relationship. There's something wrong if you're bored. And your brain is telling you there's something going on that maybe you're doing an insignificant test. Maybe you are doing something that you've done over and over and over again, and there's nothing to see here. Maybe this is a task that we better hand it off to automation. Maybe, but we don't know. You see, emotions don't come with return addresses on them. We don't know where the emotion is coming from, and we have to figure it out. So, for all these different things, fear, surprise, frustration, anxiety, anything, a level of discomfort, any of these things, we have to realize that they're part of our decision-making process, that emotions are central to our decision-making processes, and we ignore that at our peril. If we don't pay attention to that, we're going to miss important problems. So those emotional things, those feelings that we're having are signals. Question is, what are they signaling? So here's the thing that I think is really important for us to consider and think about. Anytime I'm working with a piece of software, my recognition of a problem starts with a feeling. Impatience, annoyance, surprise, a violation of an expectation. If I want to share that experience, my job is to act as an extension of the senses and of the feelings of my client, of my product owner. And so I have to be able to convey that feeling to them by translating it into something rational. You see, decisions about quality are always political and emotional. By political, I mean that they're decisions based on who has the authority to make them. And they're decisions about whose values matter. So any decision about quality starts with a decision about whose values matter. That's a Jerry Weinberg thing. So it's a political decision. It's about power. Who has the power to make the decision? And whose values matter. But decisions about quality are always emotional. If you talk to most business people, they would tell you, I make decisions based on the numbers. Bullshit. They make decisions based on how they feel about the numbers. If they like the numbers, they go with their decision. If they don't like the numbers, they change their course. So, one way that I can go about this is I recognize a problem and I say to the programmer. I want to share my experience with the problem with the programmer. And as James and I pointed out, we found this to be a kind of interesting map. Because I can call a programmer over when I see a problem, and I can just point to the screen sometimes and say, ugh, huh. Ugh. All of our communication has been tacit, no words, all based on tacit knowledge, tacit exchange, but that's usually not the way it happens. Because when I go to a meeting and we say, how's the product going? And I say, and they say, really? What do you mean by that? And I go, ugh. And they say, well, what do you mean? So I have to be able to express what I think to be a problem in terms of an inconsistency. That is, this doesn't agree with that. Using any one of the 10 things that I've just identified there. Familiarity with consistency with familiar problems, but inconsistency with explainability, the world, history, image claims, comparable products, user expectations, product purpose, standards, and statutes. And then I can move from there to a point where it's inconsistent. You get it? You understand? This is inconsistent with that. That's why I'm so upset about this. And that means that my stakeholder, my client, can start to see why this is an important thing, why my feeling about this represents a threat to value somehow or other. Now, I might use a medium, a tool, whereby I say, ooh, that looks like a problem. And I look at the specification, and the product is inconsistent with the specification, and now I can go back down to my stakeholders and explain things that way. So what oracles are tools for allowing us to share our feelings about the product, are basically our mediated desires about the product. They're ways of allowing us to explain why this desire that a customer has doesn't match with the product that we've got. Now, the stakeholder is always in charge of that, so the stakeholder might have a good reason for saying, you know what, I know it looks like a problem to you, but I've got a bigger problem on my hands. One of my problems is I have to make this ship date because the client has told me already they are going to accept whatever we give them as long as we tell them about the problems in the product. They're willing to deal with that, and therefore you, Michael, should not be so upset with the idea of shipping this product in this state. At which point I can say, okay, that sounds reasonable. And so my emotional reaction, my worry, my fear that this is not going to match the customer's desires is dampened. And so my product, my client and my product owner and I can be on the same kind of emotional plane. Or I can see a terrible problem in the product, explain it in terms of an inconsistency, and we can both be very worried about it and make a decision to fix it. So oracles are not only ways of recognizing a problem, they're also ways of calibrating how we feel about the product, how we feel about the quality of the product. And that's kind of cool. So examples of things that suggest problem or no problem. Well, let's start with people. Very early on, it was wonderful to hear that people in this room were suggesting that, hey, people are the first place to go to when you think that there's a problem. You can recognize a problem by consulting a person whose opinion matters, or consulting the opinion of a person who matters, or by noticing a disagreement between people who matter. So, people. A reference document with useful information. A test program that produces an example output that we say is good. Or a buggy version of the product with lots of bugs in it that produces a known bad example if it's inconsistent with that. Or a tool by which we can check output, or a tool by which we can recognize patterns of things. We can look at the product and we can see patterns of behavior, patterns of output if we visualize them or graph them. Those kinds of things can help us to recognize a problem. So mechanisms and artifacts. But then there's also feelings like confusion or annoyance or irritation or impatience or surprise or amusement. That is the first indication that we've got a problem. Finally, a desirable consistency between things that are related to each other. Now, I'm going to have to hurry because I'm officially out of time. But we're going to slip the release date because I want to show you this. We get choices about what our oracles are. And if we want to develop our skills as testers, I would argue we have to start thinking in terms of cost, value, risk, and the oracles that we're going to choose in order to help our clients recognize problems in the product. Some oracles have more authority than other oracles do. The product owner wins. But the product owner is sometimes unpredictable. Product owner they change their mind from day to day, from time to time, based on what they have to respond to in their jobs as managers of the product. Some oracles are very reliable in the sense that they're consistent. They don't change. The requirements document is very reliable because you go to it, it'll say the same thing every time. It doesn't change its mind. That might be a bad thing, but it might be a good thing because we can go back at a certain point and say, this is what it says. This is trustworthy in the sense that we can all agree that this is right or wrong. Some oracles are immediate. A feeling immediately tells us that there's a potential problem there, but they're not necessarily completely reliable. Some oracles are very precise, like an automated check that has a bug in it. Gives us an exact, precise answer. Right now, the time is precisely 21 minutes and 34.6871 seconds after 11 o'clock in the morning. That's very precise, but it's wrong. It's not accurate. So, some oracles are more accurate, but less precise, like blink oracles that allow us to see a problem in an instant, like that flight back and forth across the Atlantic Ocean. Some oracles are available to us. So you can go down the hall and ask the programmer. But the programmer is not necessarily an authoritative oracle. The programmer tells us about how the product is supposed to work, but we can always suspect that the programmer is wrong about that. And if we feel like getting into an argument with the programmer, oh man, this is a way to make testing so much faster. As soon as you find yourself getting into an argument with the programmer, say, you know what, peace, peace. You could be right. You could be right, I could be wrong. Let's go ask the product owner. Or let's ask the product, there's no point in arguing with the developer about whether something's a problem or not, because both the programmer and us, we're working for the client, we're working for the product owner. Let's not fight about it. Let's make a case as to why this might be a problem and be humble. It's important for us to be humble as testers because we could be wrong. Just like everybody else, skepticism about the product starts with being skeptical about what we think we know. All oracles are heuristic. They can all fail, and that's why we try to keep our mind open. We don't always have an oracle in advance, so we have to be ready for an oracle to pop into our head at a moment's notice, and we have to prime ourselves, train ourselves to look for problems on that basis. Because of the few hiccups list, FEWHICCUPPS, I'm never without a test idea, and I always have a way of explaining a problem when I see one. No oracle can always tell us whether a product's always working. That's why we use lots of them, in order to make sure that we don't get fooled. A program might be fooling us. Our oracles might be fooling us, and that's why we try to remain humble and think critically. We never know when a test is finished. Maybe we find out weeks later, oh my God, that would have been a problem back then, and it is a problem now. I would have recognized it weeks ago. I only recognize it now. That can happen. We can't know the deep truth about any result because we don't own it. We don't own the deep truth. The product owners own the decisions about whether the product is good or not, or whether what we're seeing is a problem. So with that, I would like to thank you very much. I know that we're under time pressure, but if you have any questions, I'm hanging around. There's going to be some kind of ceremony afterwards, and I'm happy to talk about this stuff. The notes for this will be up on the web. Спасибо.
Well, thank you. We have time to one or two questions.
Oh, great, good.
So? Nice.
Would you wait? The trick is you wait 5-10 seconds.
Yeah.
See, there you go.
Okay, so thank you very much for the good presentation, and my question is regarding that. At least I would say a lot of customers, a lot of companies that produce develop software, they can share their defects with the end users.
Mm-hmm.
How you can command this, and maybe some tricks, what can we do? So, it will be very good if we will ask our users, would you like this fix or not? So they know about all problems, and they can,
Yeah. You said that companies don't share their defects with their customers. Oh, I don't know. I think they share a lot of defects with their customers. They should not. But that's not what you meant, is it? You meant how can we share the news? That I'm afraid that's as having been a product owner, having been a program manager. That really, unfortunately, is a business decision that businesses make. What you might want to do, if you believe that that would be a problem and if it presents risk to the company, one thing that I might do is I might say, would we like to take control of this story, or would we like to let our user community do it for us? Well, we could make an announcement about this thing that we're aware of as a problem in the product and caution our customers, or we could have it show up on Facebook. Are you okay with that? After all, as testers, there's two questions that dominate all testing. One is when we look down at the product, what we have to be asking ourselves is not, does this work? That's easy. I mean, we can make it work easily, just make sure we don't stretch it too hard. What I want to do is I'm looking down at the product, I ask, is there a problem here? I'm looking for problems, I'm trying to find problems in the product. If I see a problem in the product or in the project or in the testability of the product or in anything that could slow me down or make things harder or anything where I see risk in the product, I believe it's my responsibility to ask, are you okay with this? Are we all okay with this? So my job looking down at the program is there a problem here? Looking around to my clients and to my coworkers, I want to ask, are we okay with this? Now, their program might not be very testable. It might be slow, right? It might have no automation interface to it. But you know what? That's all right. If everybody else says that's okay, I can deal. But what I will also say is this is going to slow down testing. It's going to make it harder for me to understand the product. Are we okay with that? Because any issue that gets in my way, slows things down or makes it harder, gives bugs more time and more opportunities to hide out. Anything where it looks like a risk to the business, we've got this problem in the product, we're not letting the customers know about it. Your call, product owner, but are we okay with this? It's my job to develop a justified, a reasonable reason why we might not be okay with this, but if the product owner is saying, no, we're okay with this, then it's my job to say, okay, thank you, as long as you're aware of the problem, I've done my job. The thing is, I don't want to mess up by not telling them about a problem such that they understand it. They have to be able to understand what I'm concerned about. After that, if they understand what I'm concerned about, and they get it, and they say, no, we're doing something different, it's not my job as a tester to say, but you can't do that. I'm not the boss of them. Any other questions?
Well, can I ask one?
Yes.
Is it really no place for feelings or emotions in software development?
I don't think there's any place for emotions in software. Thank you. Thank you very much.